Hey Kacper,
Hello.
tell us a few words about yourself and about the tool you want to show us.
Yeah, thank you very much for having me today. There is a tool that I'm personally really excited about, not because I joined the company which is responsible for creating it, but basically there is a really hot topic in machine learning happening nowadays, and this is neural search. And Qdrant, a tool that I'm talking about, is an open source vector database trying to make the neural search faster and simpler for anybody who would like to have it implemented in their own project. So basically, Qdrant is a relatively new tool. It was created less than a year ago, and we are strongly working on making the version number one, which will be a stable production ready system for having the vector search done within a few minutes.
Sounds pretty exciting. I want to see it.
Yeah, that's I really believe that a picture is worth 1,000 words. So it's quite hard to describe a vector database. I could show you the Rust code, which is under the hood, but probably that won't work that well. So what could work would be a demo of something that you could achieve very easily by using Qdrant. Let me just share my screen then.
You said you used Rust, so it's not Python.
No, it's written in Rust. We really care about the performance, and Python cannot offer a good performance when it comes to efficiency of vector search. So Rust was the first choice. There are various reasons why we decided to go for Rust, and that was a pretty good choice. Just by looking at some numbers, we are achieving a much better efficiency comparing to the other tools that are available in the market. So today I would like to share a few examples of using Qdrant for creating some tools. Those examples are pretty simple, but they clearly show how you can implement visual search, but not only, using Qdrant in some publicly available models. So the first example is about food discovery. This is also available on our website, and this simple tool allows you to look for a meal just by providing some positive and negative examples. So let's say today I would like to eat more healthy than typically, so I would go for a Caesar salad. Yeah, so by providing those negative and positive examples, I can just select a meal that will be visually similar to the ones that I created, but also quite far away from those ones that I do not like. And if I was in Berlin, I could also try to search for a restaurant that could serve me those six examples. But unfortunately, I'm not, so I cannot show it. But basically, under the hood, we have a simple tool that allows you to query using the vector embeddings of those images, and allows to perform this search very quickly. Just to give like a rough introduction to how we do it. Basically, Qdrant is a vector database built on top of HNSW algorithm, which stands for hierarchical navigable small words. And instead of making like a full k-nearest neighbors algorithm to find the similar examples, we are creating graph-like structures just in order to make an approximate neural search. And that works pretty well. Of course, it cannot offer like the same accuracy of lookup like a typical k-nearest neighbors, but definitely the performance is much better, because under the hood we have thousands of different images, and that could be found easily within a fraction of a second. And this is quite a hot approach to make any vector database. But what makes us different to other tools is the extended filtering mechanism. Like there are two different strategies available on the market. First one is a pre-filtering. So within the search operation, first of all, we need to apply any additional criteria. Let's say I would like to search only for vegan food. then those images would also have some other attributes, like if it's vegan, probably there will be a Boolean flag that this meal is vegan. And definitely this cannot be simply incorporated in the embeddings created by any model, and that has to be stored as an attribute or as a payload, as we call it in Qdrant. And the simplest approach is to perform like a pre-filtering, but it doesn't scale well. I mean, let's say we have only vegan meals available in our data set, or there are like 90% of vegan meals. And if we apply the pre-filtering method, then simply we will need to store a list of almost all the entries from our database. So that would be fairly similar to a full table scan in traditional SQL-like databases. And that won't scale well if we have millions of examples. And there's also another approach, like post-filtering, which is typically done at the end of the search process. So once we perform the vector search, we can also check all the results and filter out only those entries which matches our criteria. Basically, this is also a valid approach. However, as a result, on the other hand, we could go to the point where we won't receive as many results as expected. And what makes Qdrant different is our unique approach to incorporate this filtering directly in the vector search phase. And we do that by providing some additional edges in the created graph, but this is quite complex topic, so I would be happy to put some reference link to a blog post created by our CTO describing this approach. But that makes Qdrant blazingly fast, including all those additional filtering criteria.
I'm just wondering if you have code for this one. Like, I'm really curious to see how it's implemented, because I expect that like on the back end you have Rust, right? But then like usually data scientists do not use Rust, right? So we are more like Python folks.
Yeah, definitely.
I guess there is a way to somehow use the Python interface, right?
Exactly.
Maybe you have the code for this one. I'm really curious to see how it looks like, if it's Python or not, and what is there.
Yeah, definitely. We have a Python client, so I think we can share this code as well. Basically, we know that majority of data scientists would use Python on their daily basis, and they shouldn't care about the technology that we use to create this database. It's like PostgreSQL or any other database that you could try to use. So we offer a Python client, which is currently using either HTTP or gRPC protocol, but from your perspective, that won't really matter, because at the end of the day, you will just call the search or recommend or any other method that we expose. So there is a different project that we also maintain a Qdrant client for Python.
I see. It's more like client-server architecture, not
exactly.
like in case of Face. I think Face is written in C++, or maybe something like they don't. Not everything is in Python, right? But they just call they make the call to the native code from Python, right? So the thing still lives within one process. But for you have like this client-server architecture, right?
Exactly. We are rather a product that you could use in production. If you use Face,
like
then you still
search, right?
Exactly. This is like a tool that we are quite often compared to, because many people use Elasticsearch to perform the search based on some attributes, but they also provide the support for so-called dense vectors. And this is possible, of course, to do with Elastic, but just by looking at some numbers, we are typically like 10 times faster in those operations, just because we are created purely for vector search. And this is like our major feature. Definitely, we can share the code of those examples. I think that may be a valuable thing. But comparing to Face, this is like a library that you could incorporate in your project, but maintaining all the calls to the library may be quite hard, and also require some more knowledge about the library itself, even though if you use Python. But as a data scientist, we don't necessarily need to know anything about how it is implemented. Here with Qdrant, you only care about deploying it using a Docker image. And that may be like a single tool per organization where you could manage all the vectors that you store. So basically, this is like a production system, not a library that you still need to maintain. So that makes us different. So Elasticsearch is like a similar tool, but they are designed to support some different use cases.
Yeah, clear.
Yeah, and this is also worth noticing that we are not focusing on the vector embeddings. Qdrant just exposes an API, and you can put whatever vectors you want. Then you just select the distance functions that you would like to use to compare the distances between different vectors, and that's it. But still, the data scientists will be responsible for creating those embeddings and putting them into the database. So you are free to experiment with different embeddings and trying different approaches to solve your problem. But we are not forcing you to use a single specific model to create those embeddings, and we can support different dimensionality. And also quite a fancy and yet simple trick. But you could also like create different collections, and apply some aliases on top of those collections. So then, even in production, you can simply switch between the old and the new collection by a single atomic API call. So that's really cool. And creating such an example takes a few hours. If you already have some embeddings created, then you can simply create a simple front end and use it as a database without worrying about setting this up. But
so
also,
in this case, you have like a neural network that sees the image of food and it produces an embedding, and then you index these embeddings, right? And then, so this is the indexing phase, and then the lookup phase, the search phase is just okay, I want something similar to these two, but something not similar to these two, and it
exactly
gives 6 results.
Exactly.
Quite neat.
And this neural network, if you want to make this search allowing you to query for some positive and negative examples, how we call it, then you probably will need to train your neural network in a different way, perform so-called metric learning, which is also something in the scope of using Qdrant, definitely something really exciting. But yeah, there are also some simpler cases, like when you only want to look for positive examples, then you could probably use any network you want and those embeddings without any further fine-tuning. So this is also really cool, and this is also visible in the second example that we have. So if we can just switch to it. Basically, this example shows how to search for both positive and negative examples, and then takes only the ones which are similar to the positive ones. But let's say if you have any e-commerce system and you would like to allow your customers to perform a visual search. So this is fairly good example, I believe, because let's say I want to buy a piece of cloth and I have a picture of something that is similar, but also I would like to have a specific fabric, or I'm interested in buying this piece of cloth in a specific size. This is not only a visual search, but there are also some other attributes that I would love to filter by. And to create this example, we took an H&M data set from Kaggle. There was a competition that has ended like a month ago. And we did that in the simplest way possible. So we didn't care about any fine-tuning of the models. We just used ResNet 18 for embeddings without any further processing of this specific data set. We, of course, use Qdrant for storing those embeddings, and took Streamlit as a front-end layer just in order to make it possible within a few clicks. So basically, that offers like two options. If I had a picture of a piece of cloth I wanted to buy, then I could upload it, and that will be vectorized and then used for the vector search. But also, I can try to find something that Keanu Reeves loves to wear. So by clicking on the image, I can just try to find some some pieces of cloth that are similar to the ones visible on the picture. And also, if I wanted to have like a different color, let's say I would love to have a jacket, but in a different color, it could be just blue. Then it will also filter based on those attributes. And under the hood, it just asks Qdrant. But as you could see, it takes a fraction of a second to perform a vector search combined with those extended filtering. And this is really cool. I think there are many different use cases for creating that. Honestly, I was using Google Lens for different checks when I was planting some flowers on the balcony. I was trying to find the name and how often I should water them. And that could be quite hard to be done if I had to put a textual description of the flower itself. But with Google Lens, that was like the easiest way possible. And the same is for Qdrant. You could actually use it to perform any visual search you would love to, also with those additional attributes. So this is fairly simple and available as a tool. So I would say the simplicity of Qdrant is something that everybody interested in a neural search would really admire.
Is it running right now on your computer?
No, this demo is also publicly available. It is hosted under on our servers, and also it's open source, so you can also have a look at the code itself and check whether you could probably already use the same pipeline for a different example. As I said, it's using ResNet 18 directly from Torch Vision, so it's nothing really fancy. And there was no fine tuning. So actually, I was able to create this app within a few hours once I found the proper data set.
Looks quite cool. But in principle, you can just do, I don't know, Docker Compose app or just Docker run, right? And then
definitely running that on Docker is the preferred way. Actually, that's something that I would love to announce. But this week we have published a Helm chart, so it is also possible to deploy Qdrant effortlessly to Kubernetes cluster. So if anybody works,
after the recording, please share the link and I'll include this.
Definitely. I will.
People will be interested.
Okay, that's cool. So this is also possible. So this is fairly easy. It's like if you use Docker or Kubernetes, then you can run it within a few minutes. And the default configuration allows you to start right away. There is no need to worry about any specific options. I wasn't really playing with that a lot. The only thing that I was doing was to create those embeddings. That was the hardest part because that took a bit time on my laptop.
Yeah, especially if you need to train like a triplet loss model, something like this, right? So
that may take some time, but hopefully we can also, I cannot tell more about that, but probably we will be able to solve at least part of the problems with training those triplet loss functions. So that should be more efficient, but probably we can talk about this other tool on a different occasion when it's published.
Yeah. Okay, we'll keep an eye on what you do. Okay, how many people actually work on this?
Yeah, today we had an onboarding of another member of a team, so there are 14 of us, and most of us are working in technical domain. There are a lot of Rust developers on board, but we have a cloud team that purely works on making the Qdrant deployable on any cloud provider, at least the major ones. But also on this Helm chart. So basically, we are going to cloud. We believe that this is the only way that we could scale it up. So 14 people already, and we are growing. So hopefully the team will be bigger in the upcoming weeks and months.
Are you looking for people? Are you hiring right now?
I'm not sure, honestly. I think that we are in the final shape of the team, at least until the first version is going to be published. But this is going to be published within a few months. So basically, if you found it interesting, then I really encourage you to send your resume, and probably we are going to be extending in the nearest future.
Okay. You noted a bit on your plans. At least you told us about a different tool that you might have in the future that might help with triplet loss neural networks. But I'm wondering, what are your plans in the nearest future for Qdrant, or what is next for it?
Yeah, definitely the majority of our plans is related to cloud deployment. Right now, this Qdrant can be deployed on Kubernetes or using Docker image, but definitely the plan is to make it scalable. So you cannot right now you only can run a single instance, but we want to have it run in a distributed mode, and then making Qdrant available in the cloud is, I would say, the most important topic.
Okay, got it. Yeah, I think you mentioned that when you were talking about expanding the team. And if somebody wants to contribute, how can they do this?
Yeah, we really appreciate any comments of using Qdrant. We have a Discord community, so if anybody is interested, we can also put a link to it. I would really encourage you to join. We are eager to help with your projects. If you are working in neural search, we have a community of early adopters, and we are still looking for some others. So hopefully that would be the best way. Start using the tool and letting us know how you feel about it and what could be done in a different way. We are open to discussion. But also we are an open source tool. So we have a GitHub repositories for storing the code, and we use GitHub issues. So if you see any issues or bugs in our software, then please let us know. Or if you just want to contribute as in a more technical way, that we are also open to any pull requests if you find something really important for vector search. Then
do you have any good first issues for code contributions? Like maybe there is a bug that you don't have time to fix, but maybe somebody, I don't know, could jump in and solve it for you?
there are some issues that could be good for as a first choice, as a first contribution. But honestly, guys are working on that in a so fast manner that that I might not be up to date with that. I didn't check it today morning, so hopefully I can just have a look today. But because the good thing about Qdrant is that everybody inside in the company is really excited about making that work. We see that there's plenty of opportunities for using the neural search. So basically, those issues are typically solved quite easily. But probably we can find something that would be interesting, also for the newcomers.
Yeah, thanks. Do you have any advice for anyone who is watching this?
Yeah, definitely. Drink less coffee and take care about quality of your sleep.
Exercise more.
Exercise more, yeah. But honestly, before I joined Qdrant, I didn't spend much time working on metric learning or similarity learning, but definitely now I see that this is like an interesting topic, because we all got used to performing classification methods in any case, but that's really rarely the case that we have a lot of annotated data. And metric learning is something that could help you with solving those problems where you do not have an access to good quality of annotated data, or you do not have time to make that on your own. So definitely cases like extreme classification might be easily solved with metric learning. So I really encourage you to have a look, because that might be something that will dominate the market in the nearest future, because the simplest problems in classifications have already been solved. So I think that might be the future.
And FICE is painful to use, so I know that.
Yeah, and annoy is just annoying. So
yeah, annoy is even more annoying than FICE, I think. Yeah,
definitely.
they probably selected the name. They picked up this name on purpose, right?
It's definitely done on purpose. Yeah, I also claim they did know about that.
Okay, I hope we do not offend anyone from Hanoi listening to this right now. Sorry. Okay, thanks a lot. Awesome demo. Thanks for joining us today. Thanks for showing it to us.
Thank you very much. That was a pleasure, and hopefully that wasn't the last time, because we are working on something really exciting. So hope to see you soon.
Me too. See you.